Hello, everybody. Okay, so this is our last lesson we're going to have. And what I'm going to include today is alternator testing, starter testing, and I am going to show you a proper battery load testing. So we're going to start with alternator testing. Naturally, noise, right? Noise. Alternators are driven by belts. And when we have belts, we have potential for noise. And we have potential for noise from a couple things. One is belt, dry rotted belts, glazed belts, oil soaked belts, coolant soaked belts. In relation to the belts, you have belt tensioners and idler pulleys, things like that. Now you're going to hear maybe when I show you the alternator output testing that you can have a whining noise from the alternator itself. When it goes into charge mode to really charge full force, you get a whining sound and you'll hear it. And you'll see that that whining sound could be a shorted component within the alternator as well. But that's when you'll hear it. And if you listen, I even mentioned it in the video, you may very well hear it. Not that anything's wrong, but that could lead to these things failing if it's like that all the time. Right. Voltage output test. There's two things that come into checking for an alternator. One of them is voltage and one of them is amperage, right? Current flow. So to measure voltage, we connect the voltmeter across the battery terminals, positive to positive, negative to negative of a meter. We connect a tachometer, something to measure the RPMs. So we can use the car itself, or we have tachometers that attach, test lights, things like that, that'll give us an RPM signal. We record the base voltage with the engine off. So we get a value of what that battery is, testing it without the car running. Then we start the engine, we run it at 2,000 RPMs. We read the voltage. It should be between 13.5 and 14.5, right? Something like that. Generally, if an alternator is charging, voltage will be a little bit lower. So if we have a battery that we just jump started, you'll see the voltage ends up being rather low. But if we checked with an inductive clamp, we'd see that alternator is putting out a lot. You're going to see that in the test that I'm going to show you. So naturally, we have voltage drop testing, and we've talked about voltage drop to the ends of the earth, right? We should never have voltage drop more than 3% of total system voltage. Any single wire or connection should never exceed 0.2 volts from one point to another. And the total system voltage drop should never be higher than 0.7 volts total for everything, going into a battery, coming out of a battery, anything. So basically, you have no reason to have a change in voltage through these wires, through these cables. If you do, sign of a faulty connection somewhere. Right, so current output tests. If the reading is 2 to 8 amps less than specified, the problem could possibly be a problem in the alternator called an open diode or a slipping belt. Remember, in an alternator, you have what's called a diode trio. And if one of those goes bad, you have 33% lost. If the reading is 10 to 15 amps less than specified, the problem is a shorted diode or a slipping belt, right? So you should always have up to 110% of your output. If you look on an alternator, you will see a value, and if I zoom in like this, right, you can see this is a 70 amp alternator. And most of them have something on there, but you may or may not be able to get to the label if it's there. Now, you're going to see a alternator output test in the next slide. Okay, so we're going to do charging system now. So what we're going to do is we're going to take our lead and we're going to place it around the output from the alternator. Okay, so that's wire is the battery wire to the alternator. You see right here, and it goes up. So we're clamped around it. Very simply, if the symbol, if the numbers that show up on your machine are backwards, they're negative, then you know you've got it hooked up. Okay, so our battery cables are on the battery. Our amp clamp is on the alternator. And now when we start it up, okay, so notice we're negative. I'm going to turn it around. And now you can see we're charging at 31 amps at 13.3. Now as that number comes down, the voltage will go up some. All right, so you see as the battery charges up, and we're going to let it run for a second. All right, and as it runs, you're going to see that number come down. Eventually, it'll drop down to like 0 or 1, and charging voltage will go up to about 14.2 or so. Okay, so I want to watch what happens as I turn on accessories. Okay, so you can see that alternator is now giving us 80 amps, right? And notice the voltage is still staying above 12.6, because it's taking that voltage, and the voltage drops as amperage goes up, which is why you need an amp clamp. You need to be able to see the amperage to tell if something's charging or not, because you can have 12.7. right? You're looking at that and you're saying, hey, that battery, that alternator is not charging. But it is. It's giving us 68 amps. Now you can also hear us singing. I don't know if you can hear the whistle, but that's the electrical noise of the alternator trying to charge it up. And you can see the amperage come back down and the voltage go up again. Okay, so that is an alternator output test. Now one thing that you can do is you can load up this dial, which will put a strain on it, and we can see for a quick moment what it can give us. So we could take this and we could go right, you saw 41, but notice that the alternator was charging at 80 fully loaded.